Alright guys, welcome back. We're going to be solving another question from the second chapter of the Meriam textbook, Dynamics, and we have this block A that has a velocity of 3.6 foot per second. So we have the velocity of the block A, 3.6, which is moving to the right. So that's the direction of the block A, and we need to determine the velocity of the cylinder B. So obviously the cylinder is going to go down once the system is going to move to the right. And what we're going to do in here, we have to go based on the length of the cable that goes around these pulleys. And that's going to be our displacement. And we know velocity is displacement over time. We can call this S, X, or any other variable. Or in this case, we can call it the length of the cable. So dl over dt, which is going to give us the velocity and what the question is asking us. So we have one single cable that goes around this pulley, which is this cable. So it's going to start here, it's going to go around the first and second pulley, and it's going to stop here. And obviously this length is constant. So if you just call that one L, that's going to be a constant length. And so we're trying to find the different distances that we have in here. If we just do these dotted lines on the center of the pulley, we have the movement of this cable here, which is the movement of the cable for the cylinder B. So that's going to give us the information about the velocity of B. We have this part, which is the change in the length for the block A. And as we can see, we have 3 of these here. And we have some constants here, which is this part. We also have this part that goes around the pulley. We have the cable that goes around this pulley and a little bit here too. So I'm just gonna call all the red parts constant. What we're gonna have for the length is basically we have 1 SP plus 3 of these cables here, 1, 2, and 3. So we have 3 SA. And now if we just differentiate with respect to time in here, we're gonna get the relationship between the velocity of these two. So as I said, L is constant, so dl over dt is going to be 0. ds over dsb over dt is going to give us the velocity of the block A, and again the constant is going to be 0, so this is going to be the velocity of B plus 3 the velocity of A, and that's going to be equal to 0. We have velocity of A 3.6, which shows our VV is going to be 3 times that, so basically 3 times 3.6, and it's going to be negative. As we can see, the block is going down, so it's a negative direction of, if we just call our x and y in this direction, we can see it's going to go in the negative direction of y. So VV is going to be 10.8 negative meter foot per second, and this negative sign shows that it goes downward. And yeah, hope everything was clear. Let me know if you guys have any questions. You guys take care. I'll see you in the next video. Have a good one.